Hi, I'm Baron.
I'm Tita.
I'm Gideon.
I'm Vanesha.
I'm Hanis.
And we're from Group
11.
Green chemistry is an area of chemistry and chemical engineering that focus on designing products that can minimize the use and generation of hazardous substances. And there is 12 principles of green chemistry, which is first, prevention, second, atom economy, third, less hazardous chemical synthesis, four, designing safer chemicals, five, safer solvents auxiliaries, 6. Design for energy efficiency, 7. Use of renewable feedstocks, 8. Reduce derivatives, 9. Catalysis, 10. Design for degradation, 11. Real-time analysis for pollution prevention, chemistry for accident prevention. And as group number 11, we are going to explain more specific about real-time analysis for pollution prevention. Analytical methodologies need to be further developed to permit real-time in-process monitoring and control before hazardous substances form. Statements mean that industry nowadays need to contribute in order to produce an innovative ideas or technology in order to produce an eco-friendly products.
As chemists or even a pharmacist, we conduct several experiments every day. Depending on the type of chemistry, the goal of these experiments can be to synthesize a novel target compound, designing newer chemical processes, or simply study the properties and reactivity of a compound of interest. In a lot of these cases, it is necessary to use various analytical techniques to monitor the reaction. In the case of simplest chemical reaction, let's say we have reaction A and B react together to form a product C. How do we know when the reaction is complete? Typically, we can use techniques such as MLR or TLC to see how far along the reaction has proceeded.
It might sound complicated at first, but we actually have applied real-time monitoring in our daily lives. Let's take cooking as an example. While cooking, we may want to check the heat constantly or monitor the color so that it won't be under or overcooked. We may as well do a taste test occasionally to see if we need to add more seasoning or water or anything else. We gotta check the texture until it suits our liking. We do real-time monitoring like this so we can adjust any error occurring right away. Therefore, we can obtain better results.
In many industrial settings, it's crucial to have a suitable analytic method to monitor reaction in real time. The scales of reaction performed of this plant are big enough such that issues that we typically consider being only minor ones at the research lab scales can become very problematic. An example of such a case is an exothermic reaction in which energy is released as heat. At bunch scale, one can use a simple ice bath to cool down an exothermic reaction, and even the solution temperature doesn't end up rising. This usually doesn't pose a great risk due to the small scale of the reaction.
One of the most notable cases is the 1947 Texas City disaster, in which a cargo ship containing around 2,000 tons of ammonium nitrate exploded at the port of Texas City. It was considered one of the largest industrial explosion in the United States and one of history's largest non-nuclear explosions, killing more than 500 people. The accident happens because lack of monitoring on the temperature of the ammonium nitrate package. The increasing temperature created higher reaction rate of the ammonium nitrate and eventually causing it to explode.
That's why currently there is a huge emphasis on industrial sectors, including pharmaceuticals industry, to control and monitor large-scale processing in real time, such as monitoring temperature via thermometer, monitoring pressure through barometers, and monitoring and controlling pH through pH meter. With this analytical tool, we can make sure that one process is on their safe limits. Therefore, the things that happened in Texas almost a decade ago cannot happen to us today. That's all from us today.
We would like to say
Thank you for watching.
and have a nice day!